Welcome to Generative AI Models. After watching this video, you will be able to explain the concept of generative AI models and list their various types. Who thought machines could be so creative? Generative AI models are making it possible to mimic human creativity for generating text, art, music, and video. Generative AI models are a class of AI systems that learn from large datasets by recognizing patterns and trends. By learning from the data, they use machine learning and deep learning algorithms to create new content. The design of a generative AI model changes depending on what it's designed to do and how it will be used. Some common types of generative AI models are variational autoencoders, or VAEs, generative adversarial networks, or GANs, autoregressive models, and transformers. VAEs work by transforming input data through encoding and decoding. They have three main parts: an encoder network, a latent space, and a decoder network. The encoder takes the input data and turns it into a simpler form called the latent space representation. It holds the key features of the data. The decoder then uses this latent space representation to create new outputs. The applications of a VAE model include image generation, anomaly detection, and so on. For example, the Fashion MNIST VAE model is used to generate and reconstruct images from the Fashion MNIST dataset, which includes different clothing items like shirts, shoes, and bags. It creates new, realistic images of clothing items based on the patterns it has learned from the data. GANs involve two neural networks, the generator and the discriminator. The generator creates new data samples, and the discriminator checks if the data is real or fake. Both networks train together. The generator tries to make data that looks real, and the discriminator tries to tell the difference between real and fake data. This process continues until the generator becomes so good at producing realistic data that the discriminator can no longer tell the difference. GANs can be used for image synthesis, style transfer, data augmentation, and so on. For example, GANs can be used in the fashion industry. A famous example is NVIDIA's Style GAN that can generate high-quality and realistic images of faces, animals, landscapes, and more. Autoregressive models create data sequentially, considering the context of earlier generated elements. These models predict the next element in the sequence based on the previous one. These models can generate sequences of data like text or music. For example, a music composition tool powered by an autoregressive model can generate new melodies. WaveNet is one of the examples of an autoregressive model that generates raw audio waveforms, producing high-quality, natural-sounding speech. Transformers are generally used in natural language processing, or NLP tasks. They consist of encoder and decoder layers, enabling the model to effectively generate text sequences or perform cross-language translations. For example, a multilingual chatbot uses transformers to understand and respond to queries in multiple languages. Large language models like OpenAI's Generative Pre-trained Transformer, or GPT family of models, and Google Gemini models are examples of transformers that can generate different creative text. Generative AI models can usually be categorized into unimodal models and multimodal models. Unimodal models process inputs and generate outputs within the same modality, whereas multimodal models handle inputs from one modality and produce outputs in a different modality. Modality refers to the type of data being processed. So, unimodal models handle one type of data, while multimodal models process multiple types of data. For instance, GPT-3 is a unimodal model that takes text input and generates text output. It can complete sentences, generate stories, or answer questions based on textual prompts. Whereas, DALL-E is a multimodal model that generates images from textual descriptions. For example, for a prompt like, "an elephant playing with a ball," DALL-E can create a corresponding image. Meta's ImageBind, another open-source multimodal AI model, processes diverse data types like text, audio, visual, and movement. Its unique ability to combine information across these modalities allows it to create art from mixed inputs. For instance, it can merge the sound of a flowing river with a cityscape visual, showcasing its versatility. As we move forward, these models will keep pushing the boundaries of creativity, revolutionizing industries, and enhancing human experiences. In this video, you will learn that generative AI models are a class of artificial intelligence systems that use algorithms to create new content. Generative AI model architectures include VAEs, GANs, autoregressive models, and transformers. VAEs use the encoder to convert the input data into latent space representation. Then the latent space captures the characteristics of data. And finally, the decoder generates outputs. GANs use the generator to generate new data samples and the discriminator to verify the generated data. Autoregressive models create data sequentially, taking into account the context of earlier generated elements. Transformers generate text sequences or perform cross-language translations effectively. Models can be categorized into unimodal or multimodal. Unimodal models process inputs and generate outputs within the same modality, and multimodal models handle inputs from one modality and produce outputs in a different modality.